Guess what? You guys made it to lesson 100. Can you believe it? I know this is not exactly a party blower, but it was all I could find in my house, quarantine issues. But it's a little train whistle, which I thought was really appropriate too, because you guys have been chugging along, just making it like the little engines that could all year long, and especially through the last couple of weeks. So pardon my really cheesy example and celebration, but I'm so proud of you guys. So keep at it, keep going, because you know what? There is a huge light at the end of this tunnel now, because we are in the hundreds and there's only 120 lessons in this book. So you were practically there, okay? So hang in there. You've got 20 more lessons to go. You guys can totally do this. If you've conquered 100 of them so far, you've got this, okay? So let's talk about lesson 100. Lesson 100 is about estimating square roots and irrational numbers. So as a part of this, we're going to go back over a number hierarchy today. Some of you are like, what in the world? Trust me, you know what I'm talking about, all the different types of numbers, okay? Whole numbers, integers, all that good stuff. We're just going to relook at that and how they all relate to each other. It's always good to review that. It's a very foundational concept to everything that we do, okay? So first, though, let's talk about estimating square roots. I'm going to write some numbers up here, and then I want you to take just a second to think about them. So you can pause the video after I write them and think about, what do all of these numbers have in common? See if you can come to some kind of realization when it comes to that. All right, so pause right here if you want to, or you may already know. You may be like, I totally got this. I know exactly what's happening. But if not, pause. And now we're back. Okay, so these numbers are what we call perfect squares. Why do we call them perfect squares? Because each of these numbers has a square root that is a whole number. So remember, that means that there is a number that can multiply by itself, a whole number that can multiply by itself to give me this number, okay? So for 1, it's 1, because 1 squared is 1. For 4, it's 2, because 2 squared is 4. 9, it's 3, because 3 squared is 9. Hopefully you're seeing a pattern. 16 is 4 squared. 25 is 5 squared, and so on. I'm just going to go ahead and fill in the rest really quick so that we can see it up here, and then we are moving on. Okay, so there are also plenty of numbers, you may notice, in between these numbers that are not listed. So, for example, 12 is in between 9 and 16. It's not listed here. If it's not listed in this list of perfect squares, if it's in between these numbers and it's not listed, then it's not a perfect square. Okay, so that means that it has a square root that is not a whole number. So we can't know exactly what that is, but we can estimate it using these numbers as kind of like a landmark, okay? So let's use 12 since I said that. We know that 12 falls between 9 and 16. 12 is not a perfect square. There is not a whole number that multiplies by itself to give me 12. But I can estimate the perfect square because I know that 12 falls between 9 and 16, and I know that the square roots of 9 and 16 are 3 and 4. So if 12 falls in between these two numbers, the square root of it has to fall in between its corresponding square roots. So the square root has to fall somewhere between 3 and 4. So I could estimate, and I could be like, oh, maybe 3.3, okay? So let's test that out. If I did 3.3 times 3.3, okay, I'm just gonna do some quick multiplication. Remember, when I do these calculations, I'm not gonna take forever because I know you guys know how to do this. If you wanna go back and rewatch it, just because, I went too fast for you to follow, please do. But I don't wanna spend a whole bunch of time working this out. So 3 times 3 is 9, 3 times 3 is 9, filler 0, 9, 9. We add it all up. 9, 8, 1, 10. There are 2 digits behind decimals. So that means there are 2 digits behind our decimal in our answer. So 10.89, not quite as close to 12 as I would like. So let's try 3.4. So 3.4 times 3.4. So 4 times 4 is 16. That's going to be 13. Filler 0, 12. That's going to be 10, 6, 5, 1, 1. That's definitely a little closer. So we're probably looking somewhere like 3.4, 3.5-ish, okay, to estimate that number, which, again, we're talking about the square root of 12 here. So that's approximately 3.4, 3.5, somewhere around there, okay? So let's do another example just to kind of show you this. But then we're going to move on and dive a little bit more into irrational numbers because, like I said, this is an estimation, okay? It's a representation of an irrational number. We could do this all day long and keep adding more and more decimals and go on all day long. We could do it for the rest of our lives, guys, the rest of your life, and you will never find the actual number, okay? And I'm going to tell you why in just a minute. But let's do another example first. Oh, I didn't want to erase that. Yes, I did. I'm going to erase it. We're going to erase it. Okay, so we'll just erase the whole thing. So let's look at, we want to find between which two consecutive whole numbers is the square root of 200. So the square root of 200 is between which two consecutive whole numbers? Well, the reason I was like, oh, I don't want to erase that. And I was like, yes, I do. Because 200 wasn't even a part of my list, right? That's beyond. So we know the highest end of my list was 100. And the square root of 100 was 10. So we could say, okay, well, 200 is twice as much as 100. So maybe let's try 20. So 20 times 20 is actually going to give us 400, which that's way too high. Okay, so let's like cut that in half. So cutting it in half would be like 15. And by cutting it in half, I mean halfway between the 10 that we know, 10 squared is 100, and the 20 that we tried. So halfway between there would be 15. So let's try that. And that's going to give us 225. So that's closer. Let's go a little lower though, because that's still too high. We're trying to get as close to 200 as we can. So 14 times 14, that's going to give us 196. That's pretty close. So we could say it would be approximately 14. Okay, so it's going to be between 14 and 15 because the question was between which two whole numbers does it fall? Okay, so let's go back to talking about irrational numbers real quick. In order to do that, I wanted to just kind of do a quick rundown review of number hierarchy. So let's start inside. So we'll start with counting numbers. So remember, counting numbers are like starting at 1. When you count things, you start at 1. You say 1, 2, 3, 4, and so on. So 1, 2, 3, 4. When you count things, you use whole numbers, but you don't start at 0, you start at 1. Okay, so counting numbers are like the most specific group that we have in our number hierarchy. Okay, right outside of that are whole numbers. Because like what we just said, counting numbers are the same as whole numbers, except whole numbers include 0 and counting numbers do not. So whole numbers are 0, 1, 2, 3, 4, and so on, okay? So then outside of that group, so notice I'm like making concentric circles here. That means that all counting numbers are considered whole numbers, but there are some whole numbers, specifically 0 is the only one actually, that is not considered a counting number. So we're getting broader in our groups, okay? So our next largest group would be integers. So integers are whole numbers, 0, 1, 2, 3, 4, and their opposites, -1, -2, -3, and so on in both directions, okay? So all whole numbers are integers, but then we've got all these negative ones that are not considered whole numbers, okay? Then the next largest group we have are called rational numbers. Rational numbers are all those integers plus all the things in between, like decimals and fractions that have a discrete value, meaning like 1/2 we know is 0.5. Okay, so it's an actual like value that has an end. So it's all these, 0, 1, 2, and whatever, but then numbers like 1/2, it's also negatives, but then it's also like -0.6 or +3/5, okay? Even 1/3, which is a repeating decimal. If you turn it into a decimal, it's 0.33333 repeating. So rational numbers include any terminating decimals or fractions or repeating decimals count as rational numbers, okay? So just keep that in mind. All of this fits together, okay? Then there's this separate group over here called irrational numbers. So these are completely separate from all of this, okay? So the only thing left really is things that do not fit with these. That doesn't leave us a lot. You might be thinking like, isn't that all the numbers? Okay, but this is where things like pi come into play. Pi is the most familiar one, especially for you guys, because we have learned about this and we have talked about this. So, and remember when we talked about this, I told you, I'm pretty sure I told you guys about the poster in the library that has the big pi. And it's this huge poster. When you look at it, it just looks like a big pi sign. But if you look really closely, it's made up of itty bitty lines of numbers, and they're all digits of pi. And so it's like hundreds upon hundreds of numbers on this board, and it's not even, that doesn't even put a dent in it, because pi, the numbers of pi go on forever, okay? So they are going to keep going forever. That means it is not a terminating decimal. It just keeps going, okay? When that happens, we are dealing with irrational numbers. So just like this one, we could have certain square root numbers, which is why we're talking about this, because that's what this lesson is about. So back when we said square root of 12, and we estimated that, or the square root of 200, and we estimated that. And with the square root of 12, we got close enough. We said like, oh, maybe like 3.4-ish. But we said we could keep adding numbers to that, multiplying all day long, and we would never ever get there. You can multiply it for the rest of your life and you would never ever get there, because it's a decimal that goes on forever. If you type it in your calculator, which I don't have a calculator handy, but if you type it in your calculator, it literally says, they're giving me a different one, sorry. So they're giving me the square root of 29, so let's talk about that one. If you type the square root of 29 in your calculator, the calculator is probably gonna say 5.3851648. You might be thinking, well, that looks like it has an end to it. It does look like it has an end to it, but it doesn't. The calculator is just rounding it off for you, because if you actually took this and multiplied it by itself, like this, which is what we're doing when we're squaring something, it would not give you exactly 29, okay? And that in itself proves to us that this has to be just some kind of estimation, okay? It's a pretty close estimation, but it's an estimation nonetheless. So that's why these are called irrational numbers, because there is no way to categorize them like with any end. Even a repeating decimal counts as a rational number, because we know what's happening. We know that it's just going 0.333333333. It might be doing it forever, but we know what's happening. With these, we'll never find the end of the number, because it just keeps going. So that's why we call them irrational numbers. If something is irrational, it seems to us like it doesn't really make sense. It's hard to make sense of this, right? So these irrational numbers, that's what we're talking about. When you have a radical, which that's what this sign is called, a radical, square root of some number that is not a perfect square, that counts as an irrational number. The square root of that number is an irrational number, okay? Let's see. You know what? I think that pretty much, you guys know how to order numbers. The last example in here is just ordering numbers, but really what I wanted to focus on, and I don't want to take up too much more time in this video. So what I wanted to focus on was the number hierarchy, making sure you understand the difference between rational and irrational numbers. So I think you guys got that. So great job, and happy 100th lesson. See you guys next time. Bye.